So let me just brief you in on what's happening here. So we have a teacher with two classes, 12A and 12B. So what's happening here is that in 12A, they're having phase 2 phase classes. And then in 12B, they're having online classes. And then this table here gives us the time spent teaching, right, the two classes. And then here we have the average result of 12A, right, the weekly results. And then here we have the average weekly results for 12B. So that is the data we're dealing with here. And then 1.1 says that let's determine the equation of the least squares regression line of 12A, right? So our x here is going to be the time spent teaching, right? So let me write that down. And then our y is going to be the average result for the class, right? So we have the average result for grade 12A, right? So you cannot really calculate the least squares regression line manually, right? More especially if the question has only 3 marks. So to do this, we're going to use a calculator, right? So let me show you how we actually do that. So on your calculator, you want to press mode or setup there, right? And then this menu here will pop up. When this menu pops up, you press 3, right? When you press 3, then this menu here will pop up. We're looking for the equation for the least regression line, right? That equation says that y is equals to a plus bx, right? So we're going to press 2 so that we can open this tab here, right? So I'm just going to press 2. When we press 2, we have x and y, right? So our x is going to be the time spent teaching, and our y is going to be the average results for the class, right? 12A. So let's put in the values for x. So on this table here, you can see that we have 2, 4, 2, 8, 4, 6, 12, 10, 11. So I'm just going to put that in, right? So I have 2, and then I press equals to, and then I have 8, I have 4, I have 6, and then I have 12, I have 10, and I have 11, right? That's for the x values. Now I have to go to the y values. So to go to the y values, I'm gonna move to that column there, and then I'm gonna move up to the first one. So the first y value for 12A, right, the result, we have 42 here. So I'm gonna put 42. After 42 we have 62, and then we have 48. After 48, 52, 64, press equals to, and then 63, pressing equals to again, 67, and then that's it, right? We only have 7 data points. So after you put all your numbers, you press equals to, right? And then after you do that, you're gonna press AC, just like I'm doing right now. So there we go, I press AC. When you press AC, you'll come back to this menu right here where we started. But then now we want to go and retrieve our value for A and our value for B, right? So that we can have the equation of the least squares regression line. So how do we do that? We press shift. After pressing shift, we press 1, and then this menu pops up, right? We want the least squares regression line. So we're gonna press 5 because that's where we have regression, right? REG. So when you press 5, this menu pops up. You can see that on 1 we have A, on 2 we have B, and so on. So we're looking for A, right? So let's press 1, and then an A will pop up in your screen. You press equals to, and you will get the corresponding value. So now we know that A is equals to what? 38.26. And then now we're looking for B, right? B is equals to what? So now what you want to do, you're going to press AC again, you press shift, you press 1, you press 5, and then you press 2, right? And then what is B? So B is 2.46, right? So now our equation for the least squares regression line will be y is equals to 38.26 plus b, which is 2.46 multiplied by x, right? What we're substituting in. And then just like that, you have calculated your least squares regression line. Now let's do 1.2. So 1.2 says that let's write down the correlation coefficient of the grade 12A results in respect of the time spent teaching. So we're looking for R, the correlation, right? In order to find the correlation, we're going to go back to the same menu, right? So that is shift, and then you press 1, and then we press 5 for regression, and then you can see R that is on number 3, right? So if you press 3 and you press equals to, then you get R is equals to 0.966, right? So that's just 9.7, right? If you round it off to 2 decimal places. So that's our correlation coefficient of the grade 12A results in respect to the time spent teaching. And then now 1.3 says that let's comment on the correlation between the time spent teaching and the average results of grade 12A. So we can see that we have a correlation value of 0.97, right? And then this is very high. So for our comment, we can say that we have a very strong positive correlation, right? So you just write down we have a very strong positive correlation between the time spent teaching and the average result. It seems like the more we're teaching, the more the results are going up, right? So that's a very strong positive correlation. And then now we can do 1.4. So 1.4 says that the equation of the least squares regression line of grade 12B is, and then so now we have the line for grade 12B, right? Grade 12B is given as y is equals to 15.74 plus 4.54x. And then the question says let's calculate the difference in the result achieved by each class had Miss Molife spent the average time in to complete a particular section, right? So so now for grade 12A, right? For grade 12A, let's just copy down the equation before we can go any further. We have 38.26 plus 2.46x, right? So we want to find the difference in the result achieved by each class if Miss Molife spent the average time to complete a particular section, right? So the difference, we'll be finding the difference between grade 12B and grade 12A, right? If the teacher took the average time. So what we have to do first is to calculate the average time that the teacher took, right? So to do that, we can say that X bar, you know, we're looking for the mean, the average basically. And then the time spent, we have the time here that I just circled in red. So we can just find the average of that. That will be 2 plus 8 plus 4 plus 6 plus 12 plus 10 plus 11, and then we dividing everything by the number of terms. So we have 1, 2, 3, 4, 5, 6, 7. So we are dividing that by 7, right? And then if you put that in your calculator, you should get 7.57, right? So now we have the average time spent. We can then substitute it in our two equations, right? So what are we saying? We're saying that for 12B, we're going to have y is equals to the equation 15.74 plus 4.54, and then in place of x, we put in the average time, which is 7.57, right? And then if you put that in your calculator, you should get 50.1078, right? And then if we go to 12A, so let's go to 12A. So for 12A, we have y is equals to 38.26 plus 2.46 multiplied by x, right? X is our average. That will be 7.57. So let me just put that in my calculator. and here I'm getting 56.8822, right? So now we're looking for the difference, right? So let's say the difference, let me just write that in words. So the difference is going to be equals to the highest minus the lowest, right? So that will be 56.8822 minus 50.1078, and the answer for that shall be 6.77. So that is the difference when the teacher spends the average time to complete a particular section. Now let's do 1.5. So 1.5 here is saying that let's identify an outlier in grade 12B. So let's go to grade 12B and see if we can find an outlier, right? So for 2 hours spent teaching, the average result is 9%, right? And then for 4 hours, the average time is 45. For 6 hours, 47. For 8 hours, 63. And then for 12, we have 61. For 10, we have 64. And then for 11, we have 62. So you can see clearly here that, and then for 12A, for 2 hours, we have 42%, right? So you can see that this 9% here is an outlier. It's very far away from all the other data points, right? So we can say that when X is equals to 2, and our Y is equals to 9, that's where our outlier lies, right? Because for 2 hours, we expecting an average result of around 40%, right? Because that is what is happening in 12A. So that point there is our outlier. And then 1.6 is saying that let's indicate a valid reason for this outlier. So let's not forget that for 12B, they were being taught online, right? So what valid reason can we give for that outlier? Maybe the learner was not attending, right? You just open that Zoom link and you let it play while you do something else. Or maybe the learner did want to attend, but there were connectivity issues. A lot of, issues can arise. The question starts off fairly weak with 3.1, just asking us to find the gradient of BC. So we are given all the coordinates of B, and we are also given the coordinates of C. So we're supposed to substitute directly, not trickery whatsoever. So the gradient of BC will be equals to y2 minus y1 divided by x2 minus x1. So let's take B as our second point. If we do that, the value of y2 will be 8 minus the value of y1, which is going to be 0, divided by the value of x2, which is 4, minus the value of x1, which is 5. So we have 8 divided by minus 1, which is equals to minus 8. So that is the gradient of BC. Let's move forward and look at 3.2. So what does the question say? If the distance between points A and B is equals to square root of 65, calculate the value of K. So let's put that in math. They say that the distance between A and B is equals to square root of 65. So let's have the distance formula. If we do that, we're gonna have y2 minus y1 squared plus x2 minus x1 squared being equals to square root of 65. So when we substitute the coordinates of A and B, the only unknown variable we're gonna have is K, and then that is how we are going to find it. Let's go ahead and do that. So if we take B as our second coordinate, y2 is going to be 8, and then y1 is going to be K. We square that plus x2, that is 4, minus x1, which is minus 3. So it will be 4 plus 3. We square that, and it is equals to square root of 65. Let's go ahead and solve what is inside the bracket. So we have 8 minus k squared. How do you solve that? What is 8 multiplied by 8? That is 64. And then you multiply 8 by minus k, it will give you minus 8k. You multiply that by 2, you're gonna get minus 16k. And then minus k multiplied by minus k, that is just plus k squared. And then 4 plus 3, that is 7. You square that, you get plus 49, being equals to square root of 65. So what can we do here? We can take square roots of both sides. If we do that, if we square both sides, we're gonna have 64 minus 16k plus k squared plus 49 being equals to 65. If we take 64 to the right hand side, we're gonna have 1, and then if we take that 1 back, then we're gonna have 49 minus 1, which is 48. So we have k squared minus 16k plus 48 being equals to 0. So let's go ahead and factorize. Which two numbers do we multiply and get 48? But when we add them, we get minus 16. That is minus 4 and minus 12. So that is to say that k minus 4 multiplied by k minus 12 is equals to 0. So it's either k is equals to 4 or k is equals to 12. Let's look at what makes sense between 4 and 12. B is clearly above a in terms of the y value. So if the y value of b is 8, then the y value of a should be less than 8. So this k is equals to 12 cannot be correct, meaning that the answer is k is equals to 4, the y value of a. Let's move to 3.3. 3.3, we are supposed to prove using analytical geometry methods that BP is perpendicular to AC. So what are we required to prove? We are required to prove that the gradient of BP multiplied by the gradient of AC will be equals to minus 1. That's what we mean when we say BP is perpendicular to AC. So let's go to our sketch and see how we can find our way. So where is BP? BP is right here, and then AC is right here. There we go, we have AC. So A, we have the coordinates of A, we have all the coordinates of A, and we have all the coordinates of C. So it's easy to calculate the gradient of AC, right? So we have that figured out. What about BP? We don't have the coordinates of P. P lies on BD, and we have the coordinates of D. So we can just use the coordinates of BD to find the gradient of BP. For the gradient of BP, we're gonna say y of B minus y of D divided by x of B minus x of D multiplied by AC. So let's say y of A minus y of C divided by x of A minus x of C, right? And then what is y of B? Y of B is 8 minus y of D, which is minus 4, divided by x of B, which is 4, minus x of D, which is minus 2. And then we multiply that by y of A. We know what the value of k is now. The value of k is 4 minus y of C, which is 0, divided by x of A minus 3 minus x of C, which is minus 5. So what is 8 minus 4? That is 12 divided by 6 multiplied by 4 divided by minus 8. So we have 2 multiplied by minus a half, and this is equals to minus 1. So there we go. Those two lines are perpendicular as the product of the gradients is equals to minus 1. Let's move to 3.4. 3.4, we're supposed to calculate the coordinates of F if it is given that ACFD is a parallelogram. So let's go ahead and look at F F is right here. So if it is a parallelogram, let's go ahead and connect those points. If it is a parallelogram, then A and C, D and not A and C, but C and F, and then D and F. Yeah, we have something like this as our parallelogram, right? So in order to find the coordinates of F, we can use the midpoint of DC as it will be the midpoint of AF, but that is a painful exercise. Instead of doing that, we're gonna use translation. Let me show you how, if you're not familiar with the concepts. So let's look at the x value of A. The x value of A is -3, and the x value of D, it is -2, and then the x value of C is 5. What will be the x value of F, right? So the way the x value of A and D differ is the same way the x values of C and F are gonna differ if A, C, D, F is a parallelogram. So here we have -3 and -2. You can see that from A to D is +1. Here we have 5. So for the x value of F, we must have 5 + 1, which is 6. So we have covered the x value of F. Let's look at the y values. The y value of A is 4. The y value of D is -4. So from 4 to -4, that is -8. What is the y value of C? The y value of C is 0. So the way the y value of A and D differ should be the same way the y value of C and F differ. So that will be 0 - 8, which is -8. So the coordinates of F is 6 and -8. Yeah, so you can do that instead of using the midpoint. Right, let's move to the following question. 3.5. So 3.5, calculate the size of EDO correct to 1 decimal place. So let's go to our diagram and look for EDO. EDO is this angle right here. This is EDO. How can we possibly find EDO? Well, I can see fairly quick that I can find the value of this angle here. If I find the value of that angle, then that angle will be equals to this angle. I think they are called vertical opposite angles, and they're supposed to be equals to each other. So I can use that angle to find this angle. And then I can find this angle. And then that angle should be equals to our angle of interest plus this angle here. The exterior angle of a triangle is equal to the sum of the two opposite interior. So how can I find this first angle that I'm claiming I can find? I can use the gradient of BD. I can use the gradient of BD, which I already have, because tan theta is equal to M. And then how can I find this angle? I can use the gradient of AD to find that angle. So let's go ahead and compute that. We're gonna see that tan of that angle is equals to the gradient of BD. That angle will be equals to tan arc of BD. But we have the gradient of BD. We calculated it when we were trying to prove that AC is parallel to BP. And it was 2. So what is tan arc of 2? That will give you so yeah, that angle is covered. Let's find this exterior angle of our triangle. We're going to use the gradient of AD. So we're going to say that that angle, what is it? Is it alpha? Yeah, we're going to say that alpha is equals to tan arc of y2 minus y1 divided by x2 minus what am I doing? I already have the gradient of that line, because this line is supposed to be parallel to this line because our shape is a rhombus, right? So we said that the gradient of this line is -8. So we're gonna go ahead and substitute that. So we have -8. This will give you -82.874875. If it is minus, you must always end 180. If you do that, you're gonna get 97.125. So now we can say that our exterior angle is equals to 64.63 plus EDO plus our angle EDO. But we know that alpha is 97.125. So let's take 63.63 to the left hand side. We're gonna get 97.125 minus 64.63 being equals to EDO. If you put that in your calculator, you should get 33.7 being equals to EDO. The last question, let's do the last question. We're supposed to calculate the area of ADC. We're supposed to calculate the area of ADC. Let me highlight ADC because I cannot even see it. It's just a mess. With A is right here, and then D is right here. With C is right here. Because our shape is a rhombus, we have a 90 degrees angle here, and then if that is the case, then we can take AC as our base and DP as our height. So we can say that the area of triangle ADC is equals to half AC multiplied by DP. So we have the coordinates of A and C, so we can easily find AC. We have the coordinates of D, but we can find the coordinates of P using the midpoint theorem. So we basically have DP. Now it's just a matter of putting that in your calculator and finding your final answer, which should be equals to 30 square units. Write the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared. We are given an equation. It is said to be x squared plus y squared minus 4x minus 2y minus 13 is equals to 0. Before we do anything fancy, let's just group their like terms. If we do that, we're going to have x squared minus 4x plus y squared minus 2y. Let's take the constant to the right hand side. If we do that, this is going to be equals to 13. The next step you probably want to take is to complete the square. What do we mean by that? So we have x minus 4 divided by 2 squared plus y minus 2 divided by 2 squared being equals to 13 plus minus 4 divided by 2 squared plus minus 2 divided by 2 squared. There we go. So we're gonna have x minus 2 squared plus y minus 1 squared being equals to 18. So that is the equation of the circle. Let's do 4.2. Write down the coordinates of n and the length of nt. So n is our center of the circle and nt is the radius. So the coordinates of n from our equation, the x value is going to be 2 and the y value is going to be 1 at the center. So we're saying that the x value is 2 and the y value is 1. And then how can we find the length of nt? Like we've already deduced, nt is the radius, and on our equation we have radius squared. So we can go ahead and say that nt is equals to the square root of 18, because 18 is radius squared and nt is our radius, so nt shall be equals to the square root of 18. Let's move to 4.3. So in 4.3, determine the equation of the tangent qt in the form y is equals to mx plus c. So let's go ahead and do some analysis. We have qt right here as our tangent. In order to find the gradient of qt, because we need to find the gradient if we want the equation, we're going to have to find the coordinates of t. Well, we don't have to necessarily find the coordinates of t for the gradient, because we can just use the coordinates of n, which is 2 and 1, and the coordinates of p. But then in order to find c, we're gonna need a point that lies on the line qt. So let's just go ahead and find the coordinates of t, and then I'm gonna use the coordinates of t to find the gradient, and after finding the gradient, we're gonna use the same coordinates of t to find c. So how are we gonna find the coordinates of t? TP is a diameter, so that tells us that n is the midpoint of PT. So we can use the midpoint theorem. We can say that x of n is equals to x of t plus x of p divided by 2. So x of n, that is 2, x of t is what we're interested in. X of p is 5 divided by 2. If we cross multiply, we get 4 is equals to x of t plus 5. So x of t is equals to minus 1. Now we just need y of t. Y of n is going to be equals to y of t plus y of p divided by 2. What is y of n? That is 1. And then y of t, what we're interested in, y of p is 4 divided by 2. We cross multiply, we get 2 is equals to y of t plus 4. So y of t is equals to 2 minus 4, which is minus 2. So the coordinates of t, we have minus 1 and minus 2. So we can go ahead and find the gradient of qt. The tangent is perpendicular to the radius. So if we find the gradient of the radius, then we can use that to find the gradient of the tangent. We're going to have the gradient of nt being equals to y of n minus y of t divided by x of n minus x of t. Y of n, that is 1, minus y of t, which is minus 2. We have it right here. And then everything divided by x of n, which is 2, minus x of t, which is minus 1. So we have 3 divided by 2 minus minus 1, that is 3. So the gradient of nt is 1. Right, so now we can say that the gradient of nt multiplied by the gradient of qt is equals to minus 1. So the gradient of qt is going to be equals to minus 1 divided by the gradient of nt, which is 1. So the gradient of qt is equals to minus 1. So now we know that for our equation of the straight line of the tangent, y is equals to minus x plus c. Now we just need to find c. We're gonna substitute t of coordinates minus 1 and minus 2. If we do that, we're gonna get minus 2 in place of y and minus 1 in place of x plus c. So minus 2 is equals to 1 plus c minus 3 is equals to c. So now we have y being equals to minus x minus 3. And now we have the equation of qt. Let's move ahead and do 4.4. So in 4.4, the circle with center S of coordinates a and b touches the circle with center n externally at t. QT is a tangent to both of these circles. If ns is equals to 3nt, determine the coordinates of s. Yeah, there's a lot going on there. So let's go ahead and have a sketch for that circle and then try make sense of the situation we have. So they touch at T, and then QT is also a tangent at that circle. Yeah, another key point is that they touch externally, because if the question says they just touch, then that is very unclear. But now if we know that they touch externally, we can do something about that. Well, let's just take that as our circle and try make something of it. So it has a center S of coordinates A and B. So the coordinates of T, we have -1 and -2. What other information do we have? We're given the fact that NS is equals to 3NT. So let's try denote that in our sketch. Where is NS? NS, so this is the center of the circle S. So NS is equals to 3NT. This circle is actually supposed to be bigger than how I made it look, but well, that is that. The best way to approach a question is to start with the information that is given. So obviously, NS is equals to 3NT. That is the first thing I'll be thinking about. So NS using the distance formula. Right, let's go ahead and do that. So this is equals to 3NT. We have 2 and 1 as the coordinates of N. If we take S as our second point, we're going to have Y2 being equals to B minus Y1, which is equals to 1, the Y value of N. And then plus X2, which is equals to A, minus X1, which is equals to 2, the X value of N. If we square both sides, we're going to have B minus 1 squared plus A minus 2 squared. We actually know the value of NT because NT is the radius of the circle we started with, and that is square root of 18. So here we essentially squaring 3 multiplied by square root of 18. If we square that, we should get 162. So let's just put that there. We have 162. We know that NT is perpendicular to QT. And then we also know that QT is perpendicular to ST. So that tells us that the gradient of ST will also be equals to 1. We can actually say that y of t minus y of s divided by x of t minus x of s should be equals to 1. So what is y of t? That is minus 2. Y of s, that is b, divided by y of t, x of t minus 1 minus x of s, which is a, being equals to 1. So if we cross multiply, we're going to get minus 2 minus b is equals to minus 1 minus a. We can make 1 the subject of the formula here. Let's make b the subject of the formula. If we do that, we're going to get minus b being equals to minus 1 plus 2, that is 1, and then minus a. We divide both sides by minus, we get b is equals to a minus 1. We can call this our equation 1. And then what we want to do is to substitute this equation into this equation. So let's do that. Instead of having b, we're going to have a minus 1 and then minus 1 squared plus a minus 2 squared is equals to 162. So we're going to have a minus 2 squared plus a minus 2 squared being equals to 162. A minus 2 squared is equals to a squared minus 4a plus 4 plus a squared minus 4a plus 4. If we take 162 to the left hand side, we're going to get minus 162 is equals to 0. So we're going to get 2a squared minus 8a minus 154 is equals to 0. We can take 2 as a common factor and get a squared minus 4a minus 77 is equals to 0. So now it's just a matter of factorizing this. Which two numbers do we multiply and get minus 77? But when we add them, we get minus 4. That is minus 11 and positive 7. So a minus 11 multiplied by a plus 7 should be equals to 0. A is equals to 11, or a is equals to minus 7. So we need to pick a value that makes sense. You can see that s is on the third quadrant, so the y value must be negative. So a cannot be equals to 11, it is equals to minus 7. And now we have a. We can find b, because b is equals to a minus 1. So that is minus 7 minus 1, which is minus 8. So the coordinates of s is actually minus 7 and minus 8. This question just shows how important it is to always read the question and analyze the information before attempting any question, right? Because when I looked at 5.1.1, I'm like, okay, 5.1.1, we have cos of 2 theta. Right, so I'm going to use a double angle identity here. I'm just going to say that cos of 2 theta is equals to 1 minus 2 sine of theta squared, right? So if I find sine of theta, then it will be easy to find cos of 2 theta. But when I looked at the question again, I realized that the reflex angle itself is cos of 2 theta. So for 5.1.1, I don't have to use a double angle identity, right? I can just say 5.1.1, we have cos of 2 theta being equals to the adjacent divided by the hypotenuse, right? Because the angle itself is 2 theta that is given to us as the reflex angle, right? We're not given theta and then now we asked to find cos of 2 theta. No, we actually have the angle being 2 theta, which is a very special case. This is actually the first time I'm approaching equation and then we have something like this, right? So if we go ahead and calculate that, what is the adjacent? The adjacent is the x value of the given point, right? So there we have minus 3. So that will be equals to minus 3 divided by the hypotenuse. The hypotenuse is r, right? So we can just go ahead and calculate that with our point that is given to us, right? So we can say our hypotenuse, so we can say r squared will be equals to x squared plus y squared. So r should be equals to what is x? X is minus 3, so we have minus 3 squared plus minus 3 square root of 3 and then squared, everything to the power a half, right? We're taking square root on both sides, and if you put that in your calculator, you should get r being equals to 6. So right now we're just saying, let's not forget we're here. So right now we're just saying that cos of 2 theta is equals to minus 3 divided by 6, and then that should be equals to minus 1 divided by 2. And as simple as that, we have solved our problem. But then if you had not analyzed the question and realized that the reflex angle is 2 theta, you are going to do something completely wrong, right? And then now let's do 5.1.2, and then for 5.1.2, this is where we are going to actually use a double angle identity and not 5.1.1. Let me show you what I'm talking about, right? So we have sine of theta, right? But then even though we have sine of theta, the angle given to us is 2 theta. So we cannot say sine of theta will be equals to the opposite divided by the hypotenuse. We cannot do that because the angle given to us is not theta, it is 2 theta. That is our reflex angle, right? But then we can use the answer in 5.1.1 to find the answer for 5.1.2. So we're going to introduce a double angle identity, right? We're going to say that cos of 2 theta will be equals to 1 minus 2 sine of theta squared, right? Now you should realize that we have cos of 2 theta. 1 is just a constant. So if we are able to find sin squared of theta, then we know what sin theta is, right? So let's go ahead and solve our problem. So for cos of 2 theta, we're gonna have minus a half being equals to 1 minus 2 sine of theta squared, right? So now we just solving for sine of theta squared. So if we do that, we're gonna get minus a half minus 1 is equals to minus 2 sine of theta squared. So let's just divide both sides by minus 2. So this would imply that we would get sine of theta squared being equals to minus 1 divided by 2 minus 1 divided by minus 2, and we should get 3 divided by 4, right? Being equals to sine of theta squared. So now we just take in the square root on both sides. If we do that, we should get sine of theta is equals to the square root of 3, right, divided by the square root of 4. The square root of 4 is 2. So our answer for this question would actually be sine of theta is equal to the square root of 3 divided by the square root of 2. So all the time when you get a question like this, don't rush to assume that this angle here is theta. Always check and see if it's not 2 theta or anything else they can possibly give you. The best way to draw a graph of a trig function is to substitute all values of x but moving with an interval of 30. Because if you substitute 1, 2, 3 up to 180, you're gonna take the entire day. So you move with an interval of 30. Look at 6.1. The question here is saying that let's draw the graph of g of x if g of x is equals to minus 10 3 divided by 2x for the interval x is an element of minus 90 to 180 on the grid provided in the answer book. Clearly show all asymptotes, intercepts to the axis, and endpoints of the graph. So we are going to do that exact thing. We are going to substitute values of x in our function g of x while moving with an interval of 30. Let's see how that will look like. We are going to start at minus 90. If you substitute minus 90 into g of x, you're going to get minus 1. So that is 1 point that lies on the graph. And then if you substitute minus 60, you're going to get undefined. So we know that at minus 60, we have an asymptote. When you substitute minus 30, the corresponding y value is positive 1. When you substitute 0, the corresponding value is 0. When you substitute x is equals to 30, the corresponding value is minus 1. And when you substitute x is equals to 60, you're going to get undefined. So every time we get undefined, we know that we have an asymptote. When we substitute 90, we get y is equals to 1. When you substitute 120, we get y is equals to 0. When you substitute 150, we get minus 1. And then when you substitute 180, you get undefined. So we have another asymptote at that point, which we need to indicate. You can substitute a value between minus 90 and 60 just to see whether your graph is going up or down at this part. You shall be able to see that it is going down. And then on the other hand, we just need to connect all these 3 points, and the remaining 3 points we have something like this. Substituting values of x with an interval of 30 degrees seems to always work. Let's move to the following question, 6.2. We're supposed to determine the period of g. First of all, g of x is equals to minus tan of 3 divided by 2x. And now we're looking for the period of g of x. The period of tan of x is equals to 180. But we don't have tan of x, we have minus tan 3 divided by 2x. So how do we go from the period of tan of x to the period of minus tan 3 divided by 2x? You divide the period of tan of x by 3 divided by 2. 2, or the coefficient of x. If it's 1, you just divide by 1 and you get 180. So if we divide 180 by 3 divided by 2, we're going to get 120. If we had tan 4x, we would divide by 4. If we had tan 1 divided by 2x, we would divide by a half. So whatever coefficient of x you have, you just divide the original period with. So the period of our graph is 120. But if you look at the sketch, you can also see that it is indeed 120, because the graph can complete itself between minus 60 degrees and plus 60 degrees. And from minus 60 to 60 is 120 degrees. Let's look at 6.3. Write down the values of x in the interval minus 90 to 180 degrees for which f is decreasing. Right, let's go to our function. So at this point, it is actually quite easy to answer this question. Our graph f of x starts decreasing up to this point where it actually starts increasing again. So what are we saying? We're saying that when x is between 0 degrees and 180 degrees, our graph f of x is actually decreasing. Let's look at 6.4. So 6.4, use the graph of g to determine for which values of x will g of x be greater or equals to 1 for the interval minus 90 to 180 degrees. G of x is minus tan 3 divided by 2x. So let's go ahead and find out. We need our graph to be greater or equals to positive 1. So at minus 90, it is equals to 1. It means that this part of the graph should be part of our solution. Let's go ahead and look for other points for which it is greater or equals to 1. Again, when x is equals to 90 and going in that direction should be part of our solution. I think that's all the points for which g of x is equals to or greater than 1. When x is equals to minus 30 degrees or less, and when x is greater than minus 60 degrees, our condition is satisfied. Obviously, we cannot include minus 60 because our function is undefined at that point. And when x is equals to 90 or less and it is greater than 60 degrees, let's look at 6.5. 6.5, the function h is obtained by translating the graph of g 30 units to the right. Write down the equation of h. So h of x will be equals to g of x minus 30. Let's think about that. When you want to shift your graph to the right, you minus the x values, and then when you want to shift your graph to the left, you plus your x values. So it seems counterintuitive that how do we move right by subtracting and move left by adding? That's how it is. So h of x will be equals to minus tan 3 divided by 2 x minus 30. Right. We can further simplify this and say that h of x is equals to minus tan and then 3 divided by 2x minus 45 degrees. Let's determine CD, the distance between the two angles in terms of age. So what you want to do in this kind of problem, you will realize it towards the end, is that you have to start with the triangle that has the most information and move towards the triangle that has the least information. So let's look at our line CD. So here's CD here, right? And then apart from CD, we have an angle to theta here, which I just highlighted, right? And then we are told that AC and AD are equals to each other, right? So this angle here should be equals to this angle. So let's just, go ahead and calculate those angles. So we're saying that in triangle ADC, we have 2 theta plus angle ADC plus angle ACD being equals to 180 degrees. But then because ADC and ACD are equals to each other, we can just say that ADC is equals to ACD. The true triangles will be equals to each other since the lines are equals to each other. So now we're going to have 2 theta plus 2 ADC being equals to 180 degrees. So now we have 2 ADC being equals to 180 degrees minus 2 theta. So if you divide both sides by 2, you get ADC is equals to 90 degrees minus theta. So now we have this angle here, which is 90 degrees minus theta. This angle here is also 90 degrees minus theta. Let's not forget our aim. We want to determine line DC, right? In terms of H. So what can we do here? We can use the sine rule, right? We can say that sine of A divided by the side A will be equals to sine of B divided by the side B. We're still in triangle ADC, right? So let's take sine of 2 theta. So we're saying that sine of 2 theta divided by the opposite side, right? DC will be equals to, let's take this angle here, 90 minus theta, right? You're going to see why I'm saying we should take that one. Then we're going to get sine of 90 minus theta divided by the opposite side. The opposite side is AC. So if we cross multiply, we get DC multiplied by sine of 90 minus theta, that is just cos of theta, right? And then that is equals to AC sine of 2 theta. So DC is equals to AC sine of 2 theta, everything divided by cos of theta. But we know fully well from trig, right, that sine of 2 theta is equals to 2 sine of theta cos of theta. So we can just substitute that in. We're going to get DC is equals to AC 2 sine of theta cos of theta, everything divided by cos of theta, right? And then now it's easy to see that cos of theta and cos of theta cancel out. So now we have DC is equals to basically 2 AC sine of theta, right? But then we're supposed to determine DC in terms of H, right? So how are we gonna do that? Now, this is what I was talking about. Starting from the triangle that has the most information, moving to the triangle that has the least information. So now we're looking for the length of AC. So let me just highlight AC here for you. We're looking for AC, right? So to find AC, we're going to regard triangle ABC. In triangle ABC, we have 90 here. Here we have an angle theta. So we can use that angle. We can say that sine of theta is equals to the opposite divided by the hypotenuse. Here you can see now our hypotenuse is going to be AC, right? So we're basically done with the problem. So sine of theta will just stay as sine of theta because that angle is theta, right? So we're going to have sine of theta being equals to the opposite, which is H, divided by the hypotenuse, which is AC. And then if we solve for AC, we get AC is equals to H divided by sine theta. For the faint-hearted ones, what we did here, we cross-multiplied. We got AC sine of theta is equals to H, so AC will be H divided by sine of theta for the faint-hearted ones. So now that we have AC, right, we can substitute AC back into DC, right? So let me just do it there so that, yeah, you can see what I'm talking about. So now we're going to have DC is equals to 2 multiplied by AC. AC, we're saying that is H divided by sine of theta, right? So we have H divided by sine of theta and then multiply by sine of theta. Sine of theta and sine of theta They cancel out, so DC is equals to 2H. From the question statement, we know that our circle is centered at O. So let's go ahead and write it down. We have a center at O. What else do we know? We know that UV is a tangent to the circle at P. So we have tangent as another keyword that we are interested in. We are also told that SP is equals to SR. So we have SP being equals to SR. If you look at your diagram, you're gonna realize also that OP is equals to OR because they are radiuses. So OP is equals to OR. Look at the vertices of PSRQ. They lie on the circumference of the circle. So we have a cyclic quad. This is all we needed to answer all the questions that are gonna follow. Let's look at 8.1.1. The question is saying, let's determine, given reasons, the size of angle PSR. So PSR is this angle right here. Right, let's go ahead and look at the first keyword, center. Well, if we add the size of O1, then O1 should be 2 times angle PSR. But we don't have the size of angle O1, so we cannot use that to determine PSR. Tangent. This angle here should be equals to PSR, but we don't have that angle as of yet, so we cannot use that to find angle PSR. SP is equals to SR. It will be easy to find the size of that angle if, for instance, we had P4 or we had R3, right? And then OP is equals to OR. It has nothing to do with that angle. And then the last keyword is cyclic quad. And as you can see, angle WQP, this angle here of 106 degrees, should be equal to angle PSR. An exterior angle of a cyclic quad is equal to interior opposite. So we can say that PSR is equal to 106 degrees. That is because an exterior angle of a cyclic quad is equal to interior opposite angle. Let's move to 8.1.2. So in 8.1.2, we're looking for the size of angle R3. We're looking for the size of angle R3. So let's replace angle PSR with 106. Let's replace that with 106. So we have 106, and we're looking for the angle for the size of angle R3. R3 should be equals to P4. Angles opposite equal size. So what does that mean? It means that P4 is equals to R3. Let's start here first, and then we can see that angles opposite equal size, they should be equal to each other. So now we can say that P4 plus R3 plus PSR is equals to 180 degrees, the sum of angles on a triangle. And then P4 is R3, so we basically have 2R3 plus PSR, which is 106 degrees, being equals to 180 degrees. So R3 is equals to 180 degrees minus 106 degrees divided by 2. And then if you put that in your calculator, you should get 37 degrees. So that is the size of angle R3 and P4, because R3 is equals to P4. Let's look at the question that follows, P5. So we're looking for the size of angle P5. Right, let's go back to our keywords, because that's the only thing we're supposed to use. Can we use the center to find the size of angle P5? Well, not quite. Can we use the tangent? Let's go ahead and find out. We have the tan chord theorem. So angle P5 should be equals to angle R3. Angle P5 should be equals to angle R3. That is the tan chord theorem. Yeah, the angle between the tangent and the chord should be equals to the angle subtended by that chord on the circumference of the circle. So 8.1.3, we're saying that P5 is equals to R3 because of the tan chord theorem. So P5 is actually 37 degrees. Let's move to 8.1.4. 8.1.4, we're looking for the size of O1. Well, like we have already deduced earlier in the video, we have said that O1 should be equals to 2 times angle PSR. Yeah, the angle at the center is twice the angle at the circumference, if they come from the same arc. So O1 is equals to 2 multiplied by PSR. So this is just 2 multiplied by 106, which is equals to 212 degrees. So O1 is equals to 212 degrees. Reason being that the angle at the center is 2 times the angle at the circumference. You have to give reasons for all the statements you're making. Let's look at 8.1.5. So 8.1.5, we're looking for the size of angle P3. Looking for the size of angle P3. Yeah, that should be easy to compute. Why am I saying that? P3 is equals to R2 because they are all radiuses, right? They are all radiuses. And then if we have the size of angle O1, then we have the size of this angle POR. So we can say that POR is equals to 360 minus 212 degrees, because the angle around the point is 360. That is 148 degrees. So now in triangle POR, we can say that P3 plus R2 plus 148 is equals to 180 degrees. But P3 is equals to R2. So we can go ahead and say that 2P3 is equals to 180 minus 148. We divide both sides by 2, and P3 should be equals to 180 minus 148. That will be 32 divided by 2, should be 16 degrees. The answers to this question are actually on the question itself. Let me show you what I'm talking about. So this question here is saying that in the diagram below, A, B, C, D, and E are points on a circle centered at O. AC, OC, and ED are drawn, and then chord BC is equals to chord CD. So let's just go ahead and write that down. So we're saying that chord BC is equals to chord CD, right? And then we are told that let's select angle CED here, be equals to X, right? And then let's look at our diagram. If you look at our diagram, you will realize that AOD is a diameter, right? There it is. So here in our keywords, let's just write diameter. Why are we writing that down? Because it's important in Euclidean geometry, right? So essentially, we should be able to solve our problems with only these two keywords here and nothing else, right? Except from just the basics, sum of angles in a straight line, and so on. So let's look at 8.1. So we have 8.2.1. So 8.2.1 says that determine with reasons 2 other angles which are equals to X. So we are told by the first keyword, right, that chord BC is equals to chord CD, and we know fully well that equal chords subtend equal angles, right? So if you can see here, you will realize that chord CD subtends X, right? And then chord CD is equals to chord BC, and chord BC subtends A1, right? Equal chords subtend equal angles. So what are we saying now? We're saying that angle X is equals to A1, and then the reason for that is that equal chords subtend equal angles, right? Now let's look at our second keyword, diameter, right? What do we know about a diameter? All we know is that it subtends an angle on the circumference of a circle of 90 degrees, right? So this here is 90 degrees. But then that's all we know, nothing else. So let's go back to our first keyword and see how we can use the cos to find another angle which is equals to x. So you will now realize, if you haven't already, that not only does cot CD subtend this angle x here, but then it also subtends this angle A2 here. So that angle A2 is also equals to x because they have been subtended by the same chord. So now we can say that x is equals to A2. Why are we saying x is equals to A2? They have been subtended by the same chord, right? They've been subtended by the same chord on the circumference of our circle. So we have done 8.2.1. We can now do 8.2.2. So 8.2.2 is saying that let's determine the size of angle ABC in terms of x, right? So let me just clear these lines that I've drawn here so that we can have a bit of clarity. So we want the size of angle ABC. Yes, angle ABC here. Just place the dot. So again, we should be able to find the size of angle ABC just sticking to the basics and the keywords we have, right? In triangle, so let's regard triangle ACD, right? So in triangle ACD, you will realize that here A2 is x, right? So if you say that A2 plus this angle, which is 90 degrees, right? Plus angle ACD plus D1, this should be equals to 180 degrees, right? The sum of angles in a triangle. So now we're gonna have A2 is x, and then angle ACD, that is 90 degrees, right? And then plus D1 should be equals to 180 degrees. So D1, if we solve for D1, we shall get 180 minus 90 minus x. So D1 should be 90 degrees minus x, right? So this angle here, D1, we're saying that it is 90 minus x. Now what you have to realize is that ABCD is a cyclic quad, right? All the corners of this quadrilateral, they are lying on the circumference of the circle. So what does that tell us? We know fully well that the opposite angles of a cyclic quad add up to 180, right? So we say that D1 plus our angle ABC that we're looking for, plus our angle ABC should be equals to 180 degrees, right? It's the basics, it's not me. So what is D1? We know fully well that D1 is 90 minus x, and then plus ABC should be equals to 180 degrees. If you solve for ABC, you're gonna get ABC being equals to some 180 degrees minus 90 plus x, right? So 90, when you take it to the other side, it will become minus 90, and then minus x, it will become plus x, right? So ABC will be equals to 180 minus 90, that is 90 plus x, right? And we have determined the size of angle ABC. And then last but not least, 8.2.3 says let's prove beyond reasonable doubt that AB is parallel to CO. So let's go ahead and look at AB and CO and see what we can do there. So we have AB here, and then this is CO. And they're telling us that these two, they're parallel, right? And we're supposed to prove that. If they're parallel, then this angle here, A1 plus A2, should be equals to angle O1, right? Corresponding angles, right? So we're saying that we need A1 plus A2 to be equals to O1. This is what we are required to prove, essentially, right? So let's see what we can do here. We know that A1 is x and A2 is x, right? So A1 plus A2 should be equals to x plus x. So this is equals to 2x. So if we find a way to say that O1 is equals to 2x, then we are done with our problem, right? But then I kid you not, if you look here, you will realize that O1 is an angle at the center, and it should be 2 times the angle at the circumference, right? So O1 here should be 2 times angle E, right? And angle E is X. So now it will be easy to see that O1 is equals to 2 multiplied by angle E, right? Why are we saying that? The angle at the center should be 2 times the angle at the circumference, right? So you write that down. We're saying that the angle at the center should be 2 times the angle at the circumference, right? So now we have O1 being equals to 2 multiplied by X. So now A1 plus A2 is indeed equals to O1 because they're all equals to 2x. And then by saying that, we've essentially proved that our line AB is parallel to CO. This is the easiest question because all the answers are given to you on the statement, right? So let's look at this. In the diagram below, BOA is a diameter. We know that in Euclidean geometry, a diameter is important to us, right? So let's take that as a keyword and write it down. So we have diameter, right? And then it goes on to say that of the circle centered at O, BA is a tangent. So let's write that down, tangent, because we know that we have the tan chord theorem, and where the tangent and the radius meet, we have an angle of 90. Now let's go on and see what else we have. We are told that EA cuts the circle at D, right? And then F is the midpoint of AD. So let me show you what we're talking about. So EA cuts the circle at D, and then F here is the midpoint of AD. If F is the midpoint of AD, then this angle here should be 90 degrees, and this angle should also be 90 degrees because of theorem 1. So let's write that down. We also have theorem 1. And then that's all the information we have, right? We don't have anything else. So we should be able to get the 11 marks for this question only using these 3 statements. So let's see what happens. We have 9.1.1, which says that let's prove given reasons that OBEF is a cyclic quadrilateral. OBEF is a cyclic quadrilateral, right? So let me just highlight OBEF. So here's OB, and then we have EF, and this should be a cyclic quadrilateral. So back to the definitions, right? If it's a cyclic quadrilateral, then what should happen? O1, right? This angle O1 should be equals to this angle E. The exterior angle should be equals to the interior opposite, right? Or F1 should be equals to the entire of B. That's if indeed is a cyclic quad. So that's what we're essentially trying to prove. And then how are we going to prove it? We are going to stick to these 3 keywords that we have. So let's look at the diameter, right? Because the first keyword is diameter. So we have our diameter OB. Our diameter subtends angle D, right? Which is 90 degrees. But then that's all it does. It has nothing to do with what we're trying to prove, right? So at this point, our diameter is failing us. Let's move to the tangent. So we have the tangent EB, right? Which is subtending A. So now we can say that angle B2 is equals to A, but then that doesn't help us with anything, right? So we cannot use the tangent to answer this one. Let's look at theorem 1, right? So by theorem 1, we have already said that this angle F1 here is 90 degrees, right? We know that F1 is supposed to be equals to the entire of this angle B here, right? So now let's just say that F1 is equals to 90 degrees. Why are we saying so? We have a line from the center to the midpoint of a chord, right? That angle there should be 90 degrees. But then we need the entire of angle B to be also equals to 90 degrees. And then we will have proved that OBEF is a cyclic quadrilateral. And indeed, we can say that our angle B is equals to 90 degrees. And then you might be asking why. Why are we saying that? That is because the tangent will always be perpendicular to the radius, right? So that angle there should be equals to 90 degrees. So since angle B is equals to angle F, we have our cyclic quad because an exterior angle will be equals to opposite interior angle, as you can see. And then now let's do 9.1.2. So for 9.1.2, we're supposed to prove, given reasons, that triangle ADB, it's similar to triangle BDE. And let me tell you something, right? So the way they name their triangles in an examination, right? Angle A here should be equal to this angle B on the other triangle, and then angle D should be equal to angle D on the other triangle, and then consequently B and E should be equal to each other. So what are we saying? We're saying that let me just highlight the triangle so that we can have a bit of clarity, right? So we want triangle ADB, right? So let me highlight that. So we have triangle ADB, and then there we go, and we're also looking for triangle BDE, right? So we have BDE, right? So we're saying that angle A should be equals to angle B. So let's look at angle A here. Here we have angle A, right? We're saying that it should be equals to this angle B here. So let's go to our keywords and see which keyword we can use. You can already see that we're going to use the tangent, right? Because EB is a tangent and BD subtends angle A, right? So already here we can say that angle A is equals to angle B. And then why are we saying that? This is because of the tan chord theorem, right? And then now we can go ahead and see that angle D in triangle ADB is equals to angle D in triangle BDE. So we're saying that this angle here should be equals to this angle here, right? Which keyword are we going to use? We have diameter, tangent, and theorem 1. We're going to use diameter in this question, right? Why are we saying diameter? Because D1 is equals to 90 degrees. Why are we saying is equals to 90 degrees? It's being subtended by a diameter, right? But then at the same time, D1 plus D2 should be equals to 180 degrees, right? This is the sum of angles on a straight line, right? The sum of angles on a straight line. So you can see here that consequently D2 will be equals to 180 minus 90, which is just 90 degrees. So now D1 is equals to D2. They're all equals to 90 degrees, right? It becomes easy to see now that this angle here, B1, should be equals to the angle E, because they are the only remaining angles, right? So now we can see that B1 is equals to angle E, right? But then you don't have to say this, but then I'm just assuming that we might need to use it when we solve other problems. Let's move ahead with our equation. So we have 9.1.3. So 9.1.3 is saying, let's prove, given reasons, that OB is a tangent to the circle passing through BDE. So let's construct that circle so that we can have clarity, right? So we want a circle passing through BDE. So it's a circle that looks something like this. It's passing through B, it's passing through D, and then it should pass through E. So it's a circle like that, right? And now we have to prove that OB is a tangent. If OB is indeed a tangent, then the tan chord theorem should hold. This angle here, B1, between a chord and the tangent should be equal to this angle E here, right? Which is subtended by that chord. How can that be true? That's what we were talking about in 9.1.2, right? That the true angles of those true triangles are equal to each other. So the remaining two should also be equal, because all those angles add up to 180 degrees in a triangle, right? So now we're just going to say that B1 is equal to angle E. And then why are we saying B1 is equal to angle E? Because third angle in a triangle, right? The third angles in a triangle should be equal to each other if the other two are equal to each other. And then where is the privilege to say that coming from? It's coming from the fact that triangle ADB is clearly similar to triangle BDE, right? Like we just proved. And now we can do 9.2, right? So 9.2 says that let's prove that OF squared is equals to AD, not triangle D, but AD multiplied by DE divided by 4. So as soon as you see a question asking you to prove something like this, right? It's either you have parallel lines or you have similar triangles. If you have parallel lines, then you can play with the sides. If you have similar triangles, then you can play with the sides, right? So clearly here, we have similar triangles, so we're going to use them, right? If we had parallel lines, we're going to use the parallel lines. We know fully well our theorems. So let's look at the sides we're interested in here. We're interested in AD, DE, and OF, right? We have triangle ADB, and here we have triangle BDE, right? And then which sides are we looking for? We're looking for AD and DE. So because the two triangles are similar, we can say that line AD, right, on this first triangle here, divided by line DB on that triangle will be equals to line BD, right, on this triangle here, divided by line DE, right? The sides will be in proportion because the two triangles are similar, right? And then we must state here that we're saying that because we know fully well that triangle ADB is similar to triangle BDE, right? So now we can cross multiply, and then we can get DB squared is equals to AD multiplied by DE, because look here, DB is just BD, right? So we can just say DB squared is equals to AD multiplied by DE. And then we're not done, right? Here we have DB squared, but in what we are required to prove, we have OF squared, right? So let's try and find how DB squared and OF squared are related. It's not really easy to see here, but then 2OF is equals to DB. Let me tell you why, right? Don't forget that we have already deduced that F1 is 90, right? But then also D1 is 90. Because it's been subtended by the diameter, right? So if F1 is 90 and D1 is 90, then we know that OF should be parallel to DB, right? OF is parallel to DB. But because F is the midpoint of AD, then we have AF being equals to FD. If AF is equals to FD, then OF should be half of DB. So that is why here I'm saying that 2OF is equals to DB, right? So if we substitute that back in our equation, we're gonna get 2OF squared being equals to AD multiplied by DE. So it should be easy to see now that we're gonna get 4OF squared is equals to AD multiplied by DE. So now we're dividing both sides by 4, right? If we do that, we get OF squared is equals to AD multiplied by DE, and then everything divided by 4.